So in this lecture we shall try to find the multiple optimal solution for the linear programming model. So for example, you have given this example number 1, and you will see that instead of one optimal solution, there are many, or you can say infinite optimal solution. So again we start from the basic thing, that how we shall solve it. So we have given this x minus 4y is equal to minus 8. Are you listening to me?
Yes.
Yes,
Okay. So what we write, first of all, we write the corresponding equations to these inequalities, and we have given that we have to maximize this z function. So what we do, first of all, we shall plot, and for the plot we usually take help of the intercepts. So for 1, what is the x-intercept, or you can say if x is 0, what will be y? 2. And if y is 0, what will be x? Minus 8. And similarly for this equation number 2, what is the y-intercept? If you put x 0, y will be 8, and if you put y 0, what you will get? X 16. Agree?
sorry again, Doctor. Could you please repeat the two last point?
You just put x and y 0 and you will get it. Okay.
Okay.
You put one time x is equal to 0 and the other time y equal to 0, then you will get the required thing. You got the point?
Yes, Doctor.
Okay, so now we have to pay attention that since x and y here is greater than 0, so it means that we are interested in finding all the solution in the first quadrant. But here we see x minus 8, but this just for your, you can say 8 and 16, so 8, and here you can say minus 8 plus 8 somewhere here 16, and the maximum value of y is 2. Oops, no, 8. This is 8, so it will be 2, 4, 6 and 8. Okay, so we plot the first point for the first line is 0 and 2, so this will be x is 0 and y 2, and then he say minus 8 and 0. Since we cannot draw here because x and y are positive, so we will join this line and go through this way. So this is the line we have, x minus 4y is equal to minus 8. And now we draw the other line. We cannot draw this line because this is not in the first quadrant. Okay, what about the other line? 0 and 8. Okay, x is 0 and y is 8. So this point, and 16 and 0. X is 16 and this is 0. Now we join this line, so we have to be careful. Oops. Okay, so now we have to see that from the inequality which side means below the line or above the line is the inequality solution. So what we do now, we focus on this inequality, so we put 0 0, so 0 0, you can say test. So for 1, not fun, but this is actually, I mean, what I should say, this capital 1. Okay, and this I know is the capital 2. Okay, so what is the 0 0 test? So for 1, so we put 0 minus 0. Is it less than minus 8? Is 0 less than minus 8? I'm asking.
Bigger than minus 8.
Yes. 0 is less than minus 8?
No, it's greater than minus 8.
So not. So it
No,
means
0
this
is
is not
greater.
true. Yes. So it means that our red line was, this was the first line, and the green line was x plus 2y is equal to 16. It means that 0 0 was here. This was 0. So it cannot go down. So above that line is the solution. This arrow I just make for over, you can say, guess, to remember that it was below or above. Okay, now what about the second one? For this 2, so you put again 0 plus 0 is less than 16. 0 plus 0 is less than 16.
Yes.
Okay, yes, so it means that below this 0 0 is here, so below this is the solution. So what will be the region? So what will be the region? So you see below this line, so this will be the region. Agree? Above this line and below this line. Okay, so what will be the corner points? 1,
0 and 8,
2,
0 and
3.
2.
Okay, 0 and A. Let's say this is our point A. This is, we have to find. Okay, 0 and this is the point C. Okay, so the feasible region is shaded. Okay, and the corner points are A, and what was this, 0 and 2, and then B. We have to see what is the B, and C is what, 0 and 8. And now what we have to do for B? Any idea? We have to solve this equation number 1 and 2. Okay, to find B, solve equation 1 and 2. Solve 1 and 2, and this is what is here. So 1 and 2, when you solve, you just subtract. When you subtract, what you will get, minus 4 and minus 2, minus 6y, minus 6y is equal to, and what was here, minus 8 and minus 16, minus 24, agree, y is equal to 4, and you put in any of the equation 1 and 2. For example, you put in 1, y was your 4, 4 4 the 16, 16 comes to the right hand side plus 16, 16 minus 8 will be 8. So what is the point here? 8 and 4. Got it?
Can you repeat, doctor? I did not get how did we get the 8 and 4?
You just solve this 1 and 2, equation 1 and 2. You will get x and y. Okay?
Okay.
When you solve 1 and 2, you will get this x and y. No problem. You can do anyway. And now, yes?
I solve it by substituting A and C.
You can do any way which you like.
And
I just subtract it. When you subtract, so this will be cancel out, okay, and this will be minus, this will be minus. When you subtract x and will cancel out, you will get minus 6y is equal to minus 24. Okay.
Okay, it's clear now.
Doctor,
Yes.
can you tell me why we do 0 test?
Just to see that which side is the solution. If you don't see the 0 0, you don't understand it is above the line or below the line. So how can you check?
Yeah, okay.
Okay, so now what we do, so we use this corner and here we have z was equal to 2x plus 4y. Okay, and what was the a point? 0 and 2. What was the b point? 8 and 4. What was the c point? 0 and 8. Okay, and now you put this x and y and you will get this 8, 32 and 32. Is it clear? Are you with me?
Yes, doctor.
Yes, doctor.
So here what is the conclusion? So we are interested in finding such a point for which this z function is maximum. But we come to know that there are 2 points b and c for which the same answer. So what will be the solution?
We put them both in the conclusion.
So it means that b and c are both, but the maximum value is the same. So the conclusion is the following. So z is the maximum value, but what is actually happened here? So I just give you an idea that what is happened here. If you see this BC line, the slope of this BC is minus 1 over 2, and the slope of this maximum function is again minus 1 over 2. So you see what is the BC line here? BC was this one. So what is the slope here? If I want to write this slope intercept form, what will be this? So we have x plus 2y is equal to 16. I am talking about the line containing B and C. So this BC is on the green line. Agree?
Yes.
Okay. Now if I want to write it minus 1 over 2x plus 8, slope intercept form. Agree?
Yes.
Now what about the slope intercept form of this function? So we have given z is equal to 2x plus 4y. So we assume that this z is equal to what? Is 32 here maximum. I don't know. You can put any c. You can put any constant. Whatever. So now if you want to write in slope intercept form, what will be this? Minus 2 over 4x plus whatever is this. Agree?
Agree, doctor, but why the y-intercept in z is not important?
Sorry, what?
Why the y-intercept in z is not important? Like you said, you can put any number.
Yes, it is the 32. 32 over 4. What will be 32 over 16 over 2? 8. So, okay. So here, luckily we have the same answer, 32 over 4. And what will be this?
8.
So exactly 8. So you see, we from this equation, the maximum is same as this BC. Okay, and both have the same slope. So what is the conclusion? The conclusion is that every point on this BC line, from this to this, from this BC line, is actually the solution for this one. So what I mean, if you take this, any point, so on each point you will see that the slope of this BC and the slope of the maximum function that we are finding is the same. So it means that since the slope is same, it means that whatever is z, so z may be somewhere here or maybe somewhere here. This is parallel to this one BC because the slope is the same. If the slope is same, what this means? You remember?
They are parallel.
Infinite
Yes.
many solutions.
Yeah, they are parallel. So it means that maximum value remains the same. And this is what he said here. So each member of the family of line has the slope minus 1 over 2, as I told you here. And this is here. Slope this one and is parallel to each other. This, z. So I will give you the detail. If this happens, for example, B was this and C was this. Now there is a conclusion that how many points are there. So this is the formula. The formula says like this: x is equal to 1 minus t of this x1 plus t x2, and y is equal to 1 minus t y1 plus t y2. So this xy is, you can say, the points, the set of points which shows that for such x and y, the values of this will remain the same. And this is what is written here in detail. Okay, so we discussed this in the next lecture again. Don't worry, I will repeat this lecture. But anyhow, we have concluded that there may be many or infinite optimal solutions, but the function value is the same, which is the 32 here. And here I stop. And now I ask you to please open your cameras and position for the quiz. And rest of the thing I will discuss in the next class. Don't worry. Now I ask you to please open your camera position, and the quiz will start in just 3 minutes in the blackboard.